Hello, it's me again. I'm going to talk today about something which is so often heard and read in print, namely that we use only 10% of our brain. Did you ever hear it? This is what we are going to talk about today. I'm aware that not everyone can become neuroscientist or neurology doctor or medical professional, as a matter of fact, but somehow I believe that other people are as curious as I am, so this is my bias, of course. The thing is that it is beyond the level of comprehension that people are simply picking up some things which they confuse with facts, so-called fabricated facts. So one of the biggest misconceptions I heard over and over again is that we are using just 10% of our brain, which is of course not true. But how we can illustrate that it is not the fact? Of course, we are using science to answer questions like this. If I tell you that for the simplest of cognitive tasks, let's say recognizing a photo of someone you know, or recognizing something which is familiar, or comparing something with what you already have in your memory, it's so complicated a task that it has to use a number of centers collaborating on that. For example, if you see something, first the reflection of the light from the surface of the object or person has to come to your retina. On your retina there are transducers which are actually transducing that signal to electrical signal which goes via optic nerve to your brain. Then somewhere in the back of your head, in so-called occipital regions, the image of both your eyes is reconstructed, and in the end you have an impression that you're perceiving an object. So just in that simple task you can see that many centers are playing their role in that. For example, if I want to hold the glass of water, which is almost empty, I'm not a pessimist, it is empty, you first have to navigate your head, look at it, make a forecast how far it is, reach your hand, grasp it, see whether it is a good enough grasp or you have to change it, then move it, see where your mouth are, and try to sip and return the object. So in that simple task that you're performing every single day, a number of tasks, you're of course not thinking of how complex it is, but from using your possibility to look and see and process that information, then planning of the movement, then executing the movement, then returning the glass back. If you, for example, are engineer who has to translate the very same task in small steps to, let's say, a robot to perform it, you will see how complex it is. And if you do something similar, thinking about the motor tasks, you can see in your brain, for example, if you're in MRI, and I can see how the centers in your brain are firing, you can see that in that simple task of thinking about the movement, you have a light version of executing it. Meaning, for example, that there are research finding that if professional dancers, ballet dancers who are injured and cannot perform, even by looking on their colleagues performing the similar tasks, are actually activating the same neural pathways and a kind of keeping it in condition that they are ready for executing themselves. So my point here is that for every single task, your brain is actually using a lot of a number of centers, sometimes 10, 15, 20. So we can safely say that in most things that you do, when you're moving, when you're planning the movement, when you're perceiving something, when you're performing cognitive function, you're using the whole brain. So I wonder whether it will be too offensive when next time somebody approaches you and asks you, what do you think about the fact that you're using only 10% of brain? You should maybe answer with the question, I don't know about you, but I'm using the whole brain. I think covering this interesting topic would at least improve your arguments in talking about a similar issue. I will keep you posted about similar items that I can find in press and online and share more thoughts with you. Thank you for listening. Bye.